All right, so here's a recursive sequence, okay? This is actually a very famous sequence called Fibonacci sequence. And notice that it's not like any of the other sequences where we wrote it down explicitly or in functional form. In other words, it's not of the type 2n plus 3 over 6n minus. It's not of that type. In other words, it doesn't explicitly depend on n. Okay? So instead what it's saying is to get the nth term, you add the previous two terms with the condition that a sub 1 equals 1. Okay? That's kind of given to you right there. Then to get a sub 2, you're going to put in 2 for n here, and you're going to put it there and there as well. Oops, actually I should say you want to put actually in the Fibonacci sequence, 2 of the terms are given to you. The first 2 are given to you. Okay? And A2 is also given to you as well. So the first 2 terms are given to you. So to get the third term, okay, you're going to put 3 in here, which is equal to a sub 1 plus a sub 2. Okay? Which is going to give you a sub 1 plus a sub 2. 2, which is right there. That's your third term in the sequence. Okay? So the Fibonacci sequence is kind of different in the sense that you need to be given the first 2 terms before you can even write the third term. Okay? Now the very difficult thing in this sequence, in the recursive sequence, is that say the sequence goes on and on and on, and I want to write the 50th term. Okay? It becomes really hard because to get the 50th term you need the 49th and the 48th. To get the 49th, you need the 48th and the 47th. So you can see that it becomes extremely difficult computationally to do that, okay? But there are ways of actually taking a recursive sequence and putting it in functional form. We don't particularly learn that in this course, okay? All we learn is how to find out values of the terms in a recursive sequence. So let's take a look at the next sequence here, okay? So here's your sequence. Okay, it's given to you in recursive form. That's a recursive form. Why is that called a recursive form? Why is that called recursive and not functional? Sorry? That's right, because if you really look at the relationships there, it's not a function of n explicitly. Okay, it's a function of a sub n. In other words, it depends on a previous term. It doesn't just have to be the previous term, it can be a bunch of previous terms. Okay, it could be a bunch of previous terms. And for the recursive sequence, I'm given that a sub 1 is 25. In other words, I'm given the first term. Okay, so then to get the second term, which is this one here, I put n equals 2 in this equation here, in this one there. A sub 2 is equal to, sorry, I put 1, a sub 2 is equal to a sub 1 minus 5. Okay? And I know what a sub 1 is. 25 minus 5, that gives me 20. And then in order to get a sub 3, I'm going to go a sub 2 minus 5. Okay, which is going to be 20 minus 5, which is 15, which is this term here. Okay? Chris, you with me on this? Now this sequence here, I'm going to erase some of the stuff here, okay? This sequence here can be written as a functional form. Can you guys spend a minute writing that as a functional form? In other words, I want a sub n to be a function of n. So spend a minute doing that. Writing these sequences down. Does anybody remember from Algebra 2 what sequence this is? Pasa, you said you saw this in Algebra 2, so tell me what you saw in Algebra 2. What is this sequence called? The one that you see up there, dude. It's the same sequence. There's only one sequence, man. That one. Anybody know? In Algebra 2, you studied two kinds of sequences, or you should have. Wow, Fibonacci's in it. Yes. Which one is this? Sorry? You said geometric, so it's the opposite. It's arithmetic. Okay? It's an arithmetic sequence. Okay? And we're going to learn that formally on Monday and Tuesday, okay? All right. All right, N box. So you need to get your graphing calculators out. So today we learn the fourth mode of this graphing calculator. Okay, so we've done func, we've done PAR, we've done POL. We're going to do SEQ, stands for sequences. Okay, so put your graphing calculator in SEQ mode, and then if you go to y equals, shows up entirely differently. Okay. So for the TI-84, it wants the smallest value of n that you're going to start out with. In our case, we are starting out with 1. Okay? So n min, which is the smallest value of n, it's going to be 1. U sub n is the equation that you see for the sequence. In this case, it is 2 minus 4 over n. And for some strange reason, this calculator wants to know what the very first term in the sequence is. Even though you give it the formula, you give it the n min, it still wants you to enter what that smallest value of u is. So if you put n equals 1 in here, okay, put n equals 1 in there, it becomes 2 minus 4, which is a negative 2, which is what you enter in your calculator there. Okay, that's what you enter in the calculator there. So everybody with me on that? Sorry? I think it automatically does that, I think. Yeah, it already gives you the curly braces. And then if you go graph that, you should see a bunch of dots. You should see a bunch of dots. Why is it a bunch of dots? Well, there's some people, I got to tell you the story in period 1. So period 1, Zach is complaining that his calculator is not giving him dots, it's giving him a line. So guess what I ended up doing to his calculator? He told you? He's really mad with me. But hey, I mean, why do you have your notes in there, man? That's messed up. That's messed up. Oh my God. Yeah, that's messed up. That's messed up.
No, but then, did you hear about his staff model? He thought he would bill it, and then he billed it, and then he carried on.
Semester 1?
Yeah. But he
Okay, so explain to me why this is a bunch of dots and not a connected line. Anybody can explain to me? Yeah, Shwarya? Yo, guys, pay attention here. Exactly. In other words, on the horizontal axis, what's the variable on the horizontal axis? N. What's the variable on the vertical axis? U. Go back to this. Go back to this. Okay, u is on your vertical axis. Remember, it used to be y1. Okay, it's not y1, it's u. And the horizontal axis is n. And n is always going from integers. It's either 1, 2, 3, 4, 5, and so on. Not any fractional numbers. Okay, that is why it's a bunch of dots. You guys okay on that? Yeah? Chris? Okay, I think that's it.